11? Okay. I'm going to go over number 11. And I'm practicing this. This is our home play from page 577. All right, number 11 says find the zeros for each function, and they give us f of x equals parentheses x minus 4 and x plus 2. Now this is where I'm going to get a lot of yes. Now check this out. Some of you last night did not graph because it doesn't ask you to graph. But what did I give you in class? Step 6 is to graph. Alright, so therefore, here we go. I'm going to go over the entire process. This is what I want to see on all the rest of when we solve equations. Here we go. When we introduced functions, what did we say f of x stood for? Y. Is that correct? So that would be my first step, changing that into y. So therefore y equals x minus 4 times x plus 2. Once we have this, now we have, and we start with our steps. Step 1, solve for y. Is it solve for y? Yeah. Step 2, substitute 0 for y. X minus 4, x plus 2. From there, step 3, factor the trinomial. It's already factored. Step 4, set each factor equal to 0. From there, step 5, solve. Plus 4, x equals to 4, minus 2, x equals negative 2. These are my solutions. X-intercepts, zeros, and I'm going to add one more term, which is my roots. And you'll understand for those, what's that?
We have to write the whole stuff like this.
Okay, let's write the whole thing in case we have our party. Thank you. So here we go. So let's graph this. Thank you, Oliver. All right, let's graph this. Here's our coordinate plane. And then our roots, or our x-intercepts, are 4 and negative 2. My y-intercept, I showed you guys that we can multiply negative 4 times 2. That gives us what? Negative 8. Negative 8 is down here. And we graph it. And now we have a reindeer. There it is.
Yay!
You guys don't see it?
Yeah, I see.
There it is. You guys see it? Yes?
Yep.
It's turning to, okay, there it is. Alright, so, once again, the process. I want all this process. For those of you that didn't do this, I hope you guys are copying this and writing it along with me. Thank you. Of course the graphs too. Bah! Let's go to number 13. Oh, alright, I'll give you guys time to finish this one. 15 seconds. Number 13, here we go. So 13 we have f of x, parentheses are equals to 4x minus 3 times 2x minus 1. So, what do I do from there, Alyssa?
Just to do y equals 4x minus 3.
That is correct. Change f of x to y. And from there we substitute y for 0. Or 0 for y. We set each factor equal to 0. Since it's already factored, 4x minus 3 equal to 0. 2x minus 1 equal to 0. Let's solve for the variable. Add 3, 4x equals 3, divide by 4, x equals 3/4, plus 1 plus 1, 2x equals 1, divide by 2, divide by 2, x equals 1/2. And let's write all the names. Thank you, Oliver. We got solutions, x-intercepts, zeros, and roots. Let's graph this. It looks like a dinosaur, all right. Okay. All right, here we go. So who notices that the x-intercepts are not greater than 1? They're fractions, right? So therefore, when you get some of these, make sure you space your units here on your x-axis so that you accommodate for the fraction, right? So half of it is about right here, 1/2. 3/4 is about right here, 3/4. And my y-intercept is what? -3 times -1, that's +3. And there's our parabola. Piece of cake?
Yeah.
All right.
I don't do that. If you're like, alright, but it needs someone to go to the entire
What?
What? Be nice. Let's go to number 14. Number 14. We got f of x equals, parentheses, x minus a times x minus b. So, what do we do from there? Isaac? Change it to y. X minus a, x minus b. What would be our next step, Isaac? Change y to 0, x minus a, x minus b. Next step is to factor. They're already factored, so therefore what do I do next, Isaac? X minus a equal to 0. X minus b equal to 0. So let's solve for x plus a, x equals a, plus b, x equals b. And these are what, Oliver? Thank you. Solutions, x-intercepts, zeros, roots. And there goes the dinosaur. It looks more like a...
Yeah, now the map is too big.
So, let's graph this. Very good question, and that's why this one was in there, because this is a conceptual one. Here it goes. First of all, our x-intercepts are A and B. What numbers are they? Are they positives? Yes. And which one comes first? And then, so therefore A is right here, B is right here.
What if you multiply to get B?
So let's see. Let's see. To get our y-intercept, we need to multiply negative A times negative B. What does that give us? What is AB. AB. So what is that? It's a positive number, isn't it? So where's that found? Is it up here or is it down here? Up here. So does it matter where we place it? No, as long as it's on this side. So therefore, AB is right there. So my parabola is right there. Does that make sense? Yeah, right? Does everybody see what we did? All right. Let's move on. Let's go to number 15. Number 15. Number 15 says f of y equals y squared plus 3y minus 4. All right. Who notices a dilemma here?
It's for what?
They inverted the variables, right?
Yeah.
So therefore, instead of f or y turning into y, what does it turn into? X equals y squared plus 3y minus 4. But the steps are the same. Substitute 0 for x, y squared plus 3y minus 4. Okay?
And when you're dressing, you dress on what?
We'll figure that out right now. Here we go. Open two parentheses. Factor the first term. Power Rangers. Negative 4. Factors of negative 4 that add up to positive 3. Negative 1 and positive 4. Alright, so it's y minus 1, y plus 4, and all that is equal to 0. Next step, set each one equal to 0, y minus 1 equal to 0, y plus 4 equal to 0. Let's solve. Plus 1, y equals 1, minus 4, y equals negative 4. And what are these called? My solutions. X-intercepts, zeros, roots.
Yay. What you do? Abbreviate and put S, S, T.
No, I like the first idea better. Alright, here we go. Does everybody see the shoe?
No, it's still a dinosaur.
Oh my goodness.
It's a shoe. Look.
Yeah, it is a shoe, but it's not a green dinosaur. I like the dinosaur. What if it's a dinosaur shoe? I like the
Alright, here we go.
Yeah.
Let's graph this. Our y, oh, by the way, since they switched the variables for me, this is all I'm going to do, watch. I'm going to label the y-axis, now it's going to be the x-axis, and the x-axis will be our what? Y-axis. So what are my y-intercepts?
Oh, I see what you mean.
1 and negative 4. What is my x-intercept? Negative 4. Let's graph this. Does everybody see the fox? Yes? Alright.
It could be Rudolph too.
Rudolph 2? I haven't seen that movie. Yes, basketball players, bye. Have a good game. I don't wish you luck because I know you guys are good.
What about the softball players?
Bam. No, you get that. Anyway. Alright, let's move on to number 19. Bye. Bye.
You don't want the other team.
19. Here we go.
All of the players have the little 2.0. No?
X squared plus 7x equals negative 10. Now, throughout the day when I was checking the home play, I saw a lot of people leave this one blank and these last three because it didn't look like anything similar to what we did yesterday. However, I was depending on that you guys caught the fact that, look up. What is the common, if you want to call it denominator, of all these? That all of them have to be equal to what? 0. Equal to 0. Equal to 0. Equal to 0. Equal to 0. Therefore, what is this one equal to? Negative 10. So that means it needs to be equal to 0. How do we change this to the 0? Add 10, add 10. Boom, that just happened, yeah? So this becomes x squared plus 7x plus 10. Does this look familiar now? Yeah. Alright, so from there, open two parentheses. Factor the first term. Power Rangers, we got 10, 7. Factors of 10 that add up to 7. Marissa?
Right?
5 and 2.
5 and 2. So this is x plus 5, x plus 2, and all that equal to 0. Finish it off, please, and graph it. I'll give you 10 seconds. Oh, my bad. 15 seconds. All right. Therefore, from there, set each factor equal to 0, x plus 5 equal to 0, x plus 2 equal to 0, minus 5 minus 5, x equals negative 5, minus 2, x equals negative 2. These are my solutions. X-intercepts, zeros, roots. And the reason we label this so often and consistently is because, believe it or not, there's still some people that still are not clear as to what a factor is. And remember, I've been labeling factor every time? So hopefully with this it will sink in. So let's graph. Alright, so our x-intercepts are negative 2, negative 5, and my y-intercept is positive 10, which is right here. Hands if you got that. Okay. Alright. Any questions with these? Piece of cake? Alright, and let's go to number 21, and then we'll turn over to do some more practice from another source. Here we go, number 21. This is the last one from the home plate. Okay. X squared plus 2x plus 1 equal to 0. So, what would be our next step from there, everyone? Factor, so therefore open two parentheses, factor the first term. Did anybody catch that it was a perfect square? Square root of the first is, square root of the last is 1. 1x times 2 is 2x, therefore it's x plus 1, x plus 1 equal to 0. If you don't see it, you can still do it the long way. 1, and this one is 2. So what factors of 1 add up to 2? 1 plus 1, that's how we get this. Yes? Alright, set each one equal to 0, x plus 1 equal to 0, x plus 1 equal to 0. What do you notice there? It's the same, so therefore we only solve 1, because it's still going to be the same. Minus 1, x equals negative 1. I'm going to solve the other one for the purpose of clarifying in your noodle what's going on. Minus 1, x equals negative 1. Do you see that this is the same as this? Therefore, on our graph, doesn't matter how many points you put on that number, it's still going to be the same point. Negative 1, negative 1, negative 1, negative 1. It doesn't matter how many I overlap, it's still 1 point. Does that make sense? What is my y-intercept? Positive 1. So my graph looks like this. Pay attention, look up. I'm going to zoom in so you guys can see it. Here it goes. First of all, did it cross the x-axis? This is the x-axis. This cross. No, it barely touches, right? That's why it's only one x-intercept. Because the minute, look up please, the minute a parabola crosses, it has to come back, doesn't it? Yeah. Therefore, as soon as it comes back, it's how many x-intercepts? 2. But in this case, it's only 1. So let me zoom out. There it is. Kind of, sort of? Yes? Alright. And that only happens with what? Let's do one more. Let's do one more just to clarify your concept. Here it goes. Number 23 cubed. Bam. X squared. Give me a number. Minus 6x plus 9 equals 0. See if you can do that one by yourself. Go. I'll give you guys 40 seconds. Alright, here goes the graph. Your roots were -3, is that correct? Okay. No? +3? Oh, +3, okay. So therefore it's 3 right here. My y-intercept is 9. So my parabola looks like this. Hands, if you got it like that? Okay, good. So let me go to the previous one. The previous one, oh, sorry. Oh, it's right here. Sorry. Look at the previous one. No. Oh, here it is. It was on the left side. It was -1 and 1. Right side, 3 and 9. So, what can we conclude in regards to these type of trinomials? Talk it over with your neighbor. What do you notice about the trinomial? What do you notice about the parabola? Go. So I heard that these kind of trinomials only have one solution, therefore the parabola only touches the x-axis. Yes? Somewhere around there? Alright, so with that said, yesterday we covered some of these. I want you to copy this one, example number 3. Tonight you're going to have a lot of practice with these kinds. Yeah. Y equals 2x squared plus 5x plus 3. Alright, let's see. Help me with this one, please. Step 1, Rudy. Change y to 0, so we're left with 0 equals 2x squared plus 5x plus 3. Pass it to someone. Isaac, next step. Factor. Uh-oh, but wait a minute, we cannot factor the first term because it has a what? A coefficient greater than 1, but I circle it to remind me to do what? Multiply that times the last term. We got 6, 5, pass it to someone. Marissa, what factors of 6 add up to 5? 2 times 3, okay? So therefore, we're going to rewrite this over here. Pass it to someone, please. Alyssa, what do I write? Uh-huh. That is correct. 2x squared plus 2x plus 3x. Where did she get that from? Instead of writing 5x, we write these two as x's right here in the middle. And then the last term. Alright, pass it to someone. Oliver, next step.
You put the parentheses around them?
Around 2 of them.
Yes,
You group. So therefore, what is GCF?
2x.
2x, and we're left with?
X plus 1.
X plus 1. What's GCF for these two?
The -3. Oh, wait. 3.
3, and we're left with?
2x plus 1.
X plus 1. So my factors are x plus 1, 2x plus 3, and all that is equal to 0. Pass it to someone else, please. Who? Alan. So Alan, we're at this point right here. What do we do from there on our sequence for solving quadratic equations? X plus 1 equal to 0. What else? 2x plus 3 equal to 0, and we solve, right? So therefore this is -1 minus 1. X equals to -1. Minus 3 minus 3. 2x equals -3. Divide by 2, divide by 2. x equals negative 1.5. And the reason I wrote it as a decimal is because I just want, I mean, I could have written that as negative 1 1/2, but you choose. You can leave it as negative 1 1/2 or negative 1.5, just so that on the graph, check this out, here's my graph. I have negative 1 about right here, negative 2 is about right here, so negative 1 1/2 is about right there, negative 1.5. And what was my y-intercept at the beginning? Let's see, positive 3, that is correct. This one, and there's my parabola. How we doing? Piece of cake? Yeah? Alright. Any questions with these? If you notice, it's coming back to what we've been practicing already with the coefficients greater than 1, right? Right. Copy this one, please. Example 5. Yes. It says x minus 2 times x equals 0. All right, Alan, pass it to someone. Haley, what do I do from there?
X minus 2 equals 0.
X minus 2 equals 0. X equals 0. And then we solve for the variable. Plus 2 plus 2, x equals 2. So these are my what? My solutions. X-intercepts, zeros, roots. Alright, let's graph this. Man, that was fast. Yeah, right? So check this out. We'll see the dilemma here. Okay, so one of the x-intercepts is 2. The other one is 0. Alright, so let's look at this. Wait a minute. Doesn't this need to have a number in order to multiply the numbers to get my y-intercept? Yeah, let's find out why it looks weird. I'm going to distribute the x in here, and I get x squared minus 2x equal to 0. What's missing here? The y-intercept. So if there's no number, what is my y-intercept? 0. So in this case, the x-intercept and the y-intercept are 1. Boom. That's cool, huh? Let's see. Boom. That just happened. That was like Michael Jordan. That's a trip, huh? Alright, so be careful with these, even though they look a little bit weird, but the process is still the same. So if I was to give you this next one, go, 20 seconds. Because I want to get to the funner one.
I think we're having this. There's more fun.
Example 6, x times x plus 4 equals 0. Go. Alright, I see most of you are already done, so here goes the graph. Was our x-intercept at 0? And our other root was at negative 4?
Yeah.
Therefore, get it? Therefore.
But how do you know it's like,
A happy face?
Yeah.
Because of this. X squared plus 4x equals 0. What did we say the other day when we saw that if this had a positive coefficient, it was like this? And if it has a negative coefficient, it's like that. Yes? And the last one. Copy this one down, please. Example, super duper mega cube. Boom. 3x squared plus x equals 6x plus 2. Yeah, I know, right? This needs to be equal to what? 0. But what do we have on this side? 6x plus 2. So how can we make this 0? Everyone. minus 6x, and minus 2 to each side. Minus 6x minus 2. These become 0, and we're left with 3x squared. What else? Minus 5x minus 2. Do you know what to do from there? Yeah. Finish it off, please. 30 seconds. You see it? All right, help me out, Isaac. I'll open two parentheses. I'll help you out. There you go. Continue. Multiply 3 times negative 2. That gives me negative 6 and negative 5. What factors of negative 6 add or subtract to give me negative 5? Let's see, 1 times 6 or 2 times 3? Negative 6, positive 1. Therefore, 3x squared minus 6x plus 1x minus 2. GCF for these two is 3x. We're left with x minus 2. GCF for these is 1, and we're left with x minus 2. X minus 2, 3x plus 1. Do we know what to do from there? Yeah, set each one equal to 0, solve, and graph. Our home plate for tonight is found on page 585. Have a good one, guys. Enjoy your home. I'll let you know. This will be up by the end of the day if you need to go and review. Okay, have a good one, guys. Enjoy your home play. See you guys tamales.